Okay, so today we're starting solving trig equations. Okay, so solving trig equations is basically algebra 2, but with trig functions. Okay, so first thing you have to know is to solve trigonomic equations, we're using standard algebraic techniques that we learned in algebra 2. We look for factoring and collect like terms, isolate trig functions and equations, and then use inverse trig functions to assist in determining solutions. So earlier in the class we talked about arc sine, arc cosine, arc tangent, and how they work. And we're going to be using those to kind of help us find solutions. All of our problems, the solution interval will be between 0 and 2 pi. Okay? Technically, there are going to be an infinite number of solutions because all coterminal angles are going to be technically solutions. So you could sit there forever adding and subtracting 2 pi. And there is a method of finding those solutions using that idea. But for right now, we're going to be using solutions that are only between 0 and 2 pi. And you are responsible for checking your solutions to make sure that they are true solutions. Because sometimes while we're doing the algebra, we end up finding extra solutions that do not work in our original equation. And we'll talk about that later. Okay? So our first one that we're going to work with, something really easy. Solve 2 cosine x minus 1. Okay? So first rule in algebra when you're solving is to get it set equal to 0. Right? When you're finding solutions, it has to be set equal to 0. So this one's already set equal to 0. We have no extra work to do there. So now we're going to isolate x. Okay? So normal algebra, isolate cosine x using algebraic skills. We get add 1 to both sides, divide by 2. We get cosine x equals 1/2. Okay? Now this is where the unit circle in your trig comes in. Basically, we're finding the solutions. We're trying to find the angles where cosine is 1/2. Okay? So determine which quadrant cosine is positive, then use the inverse function to assist by finding the angle in the first quadrant and use that angle as reference angles for the other quadrants. Okay? So basically, when we look at this, cosine is positive quadrant 1 and 4. The reference angle is pi over 3, or 60 degrees. So my solutions are going to be pi over 3 and 5 pi over 3, because that's the pi over 3 in the first quadrant and the pi over 3 angle in the fourth quadrant. So these are my two solutions for this function. Okay? So this is where the unit circle is going to come in clutch. Because you need to know that cosine at pi over 3 is 1/2. And that's how you're going to find your solutions. If you plug this in the calculator, the only solution it would give you is pi over 3. It wouldn't give you 5 pi over 3. Because the arc cosine only gives first and second quadrants back. So this is what we were talking about earlier, the difference between solving trig equations and using the inverse trig functions. Okay? So this is really simple stuff. Okay? Well, this problem is. But you have to know your unit circle in order to find the solutions. All right. Let's move on to something a little more difficult. So tangent squared x minus 1. Okay? So again, it's already set equal to 0. We're going to do some algebra here. Move the 1 to the other side. Take the square roots of both sides. And don't forget, when you take the square roots of both sides, that's what gives you that plus or minus. So don't forget, whenever you do this, the square root of something squared, you end up with that plus or minus there. Okay? So basically, we are looking for where tangent is either positive 1 or negative 1. And again, we look to the unit circle. Since there's a plus or minus, all 4 quadrants hold a solution, with pi over 4 being your reference angle. Because you go to your first quadrant, you say, okay, tangent's 1 at pi over 4. So basically my solutions are all the pi over 4s in all 4 quadrants. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. So this one has 4 solutions. And again, if you had done this with just using arctangent, you would have gotten one of the 4 solutions. Okay? So just realize that. All right, so nothing is too difficult here. Now, this is where it gets interesting. So solve cotangent cosine squared equals 2 cotangent x. Okay? So this one we're going to have to do a little bit more algebra. So, because it's not equal to 0. So the first thing we have to do is set it equal to 0. So we move the 2 cotangent to the other side. Now we have more than 2 terms with trig functions in it. So we need to factor. And the first step of factoring always and forever is getting your greatest common factor. So in this one, your greatest common factor is cotangent. So your first step is to factor out cotangent, like this. Okay? This is not anything new. So now I've got cotangent x times cosine squared x minus 2. Can I factor that anymore? Now, technically, I could factor cosine squared minus 2. That's a difference of 2 squares if you want to force factor it using the conjugates. But it's easier just at this point to set both of those factors equal to 0. So we're looking for the solutions of cotangent equal to 0 or cosine squared minus 2 equal to 0. So not any different than what we did, say, if it looked like this. And this is where you guys have to realize, if I had x times x squared minus 2 equals 0, how is this with the x's different than this with the cotangent and cosine? Is it really different? No, not as far as finding solutions. We still would have set x equal to 0 and x squared minus 2 equal to 0. That would have been our next step, because this is not factorable in that way. It's easier to just set it equal to 0. Okay? They are no different, except the one on the left has more letters in it. Okay? And we need to use a little trig. Okay? So just think of it that way. So, now that we have them set equal to 0, we're basically looking where cotangent is 0 or where cosine is either plus or minus root 2. Well, there is no place where cosine is square root of 2. That's bigger than 1. Okay? We can only use values. Remember, cosine is only between negative 1 and 1, and square root of 2 is 1.4. So there are no solutions for cosine being equal to plus or minus root 2. We only have to worry about the cotangent. So cotangent is 0 at pi over 2 and 3 pi over 2, and this has no solutions, or the empty set. Okay? There are no solutions because it lies outside the range of cosine. And this is our code for today, S0LV3TR1G. That is your code for my students today. All right, so back to solving trig. So let's look at this one. Cosine x plus 1 equals sine x. This one is way more involved, and this is something that you haven't done yet with trig. So we're going to square both sides of the equation in order to change sine into terms of cosine, giving only one trig function to work with. Okay? So remember, whatever you want to do in algebra, you have to do it to both sides, the entire side. So in this case, I'm squaring both sides. And the whole reason is because I want it to be sine squared so that I can therefore change sine squared into cosine by using the Pythagorean identity. Because even if I move the sine over to the other side, there's nothing I can do at that point to factor out. Okay? So in this case, I'm actually just squaring both sides. Then we're going to simplify by FOILing out the cosine plus 1, replacing sine squared with 1 minus cosine squared, set it equal to 0, and now I'm back to algebra 1. Okay? We factor, take out a greatest common factor, set each factor equal to 0, solve for x. So we're looking where cosine is 0 or where cosine is negative 1. Your solutions are going to be pi over 2, 3 pi over 2, and pi. Okay? Now, this is something we haven't done yet. Okay? So, yes, these are our solutions for what we've done here. Cosine x is 0, so at pi over 2, cosine is 0. At 3 pi over 2, it's 0. And cosine is negative 1 at pi. But we have to make sure that we're checking our solutions. Because we squared that at the beginning, it gave us extra solutions. So when I go back and I check my solutions in my original, if I plug in 3 pi over 2, that solution does not work. Because if you plug in 3 pi over 2 into your original, cosine at 3 pi over 2 is 0 plus 1, and sine at 3 pi over 2 is negative 1, and positive 1 does not equal negative 1. So that solution is not an actual solution. And the whole reason we got that solution is because when we changed that sine to sine squared, it gave us an extra solution. So you got to be careful. Okay? You got to be very, very careful. All right. Now the last example that I want to go through is when we have something like this. Okay? So we start off really easy. Cosine 3x. So this is a triple angle. So we did the double and the half angle, but basically this just means that when we're solving, we got to find the solutions in just a little bit of a different way. So no algebra work is needed because it's done. The cosine's already by itself. But remember, 3x refers to an angle, and we cannot divide it by 3 because 3 cosine x has to equal 1/2. So we start off finding where is cosine equal to 1/2. So we go to our unit circle. And cosine is 1/2, positive 1/2 here at pi over 3 and 5 pi over 3. Okay? So that means that this right here is pi over 3 when it's done. Okay? But what I end up having to do is I don't want to know what 3x is, I want to know what x is. So to get rid of that, we have to divide both sides by 3 because we want x by itself. So when I divide everything by 3, that means my solutions are actually pi over 9 and 5 pi over 9. Now, here's the other thing. Because we divided by 3, remember, our solutions have to be between 0 and 2 pi. There could be more solutions. So to find out if I have more solutions, I'm going to actually use coterminal angles. So I'm going to go back here and I'm going to find angles that are coterminal with pi over 3 and 11 pi over 3. And then I'm going to divide those by 3 and see if I exceed 2 pi. 11 pi over 9 is still only about pi. We're only about halfway through that unit circle. So there's still possible solutions. So I'm going to go back and do it again. I'm going to find solutions using my original ones, and again, add 2 pi. So now I added 13 pi over 3 and 17 pi over 3. Then we divide those by 3. 17 pi over 9. Is that bigger than 2 pi? Nope, still not. Because 18 pi over 9 is 2 pi. So we do it one more time. Now you could have probably stopped on the last one. Because obviously 17 pi over 9, if we add another one, we're going to end up over 2 pi. But I just want to show you, if you divide those by 3, we're now past 2 pi. So that's not a solution. So therefore, our solutions are all the way up to 17 pi over 9. Okay, and we'll do a bunch of these types of problems. Maybe not with 3x, but definitely with 2x with a double angle. Okay, but I just wanted to show you when we had to do it multiple times. All right? And that's all there is to it. So basically, we're just doing algebra 2 with trig functions. Okay? Anything we can do with trig function or algebra 2, we can do with trig functions.